Hi everybody. Today we are going to talk about double and half angle formulas. These are also identity formulas and we're going to use them to simplify. So what do I mean by double angle? I mean 2 times some angle is double, and what do I mean by half? Half of some angle, A, is A. Okay, so what we're going to do now is we're going to use these identities above to simplify expressions. So let's try example number 1. So example number 1 says sine 2a on top over 2 cos squared a. Sine 2a, you see a double angle. It's 2 times some angle. So we're going to use this formula up here. So let's go ahead and plug that in for the numerator. So the numerator is going to be 2 sine a cos a. And the denominator, we're just going to leave as 2 cos squared a. Okay, what can I cancel? Any top with any bottom, that's the same. So the 2's can cancel to 1, and one of the cosine squareds with the cosine squared on top can cancel. So my final answer would be sine a over cosine a. And sine over cosine, we know, is tangent of a. Final answer. Okay, example 2. Maybe before we subtract off this sine a, maybe we can simplify this piece first. So sine of 2a for the numerator is again 2 sine a cos a over the denominator, which is cos a. And I see right away that these can cancel, the cos a's, so I'm left with just 2 sine a. So that 2 sine a is this simplified. So I've got 2 sine a minus 1 sine a. And if I have 2 of something and take away 1, I'm just left with 1. So the final answer is sine a. Okay, number 3. Let's maybe simplify the top first. I see cos 2x. Now, there's 3 formulas for cosine. Now, no matter which formula you use, you'll still get the right answer, but let's pick one that makes the most sense. And the one that I think that's going to make the most sense is going to be this one here. Because you see how this one only has sine in it, this one has cosine in it, and this one has both cos and sine? Like, the bottom of this fraction is sine. So if I pick the one that has sine in it, I have a chance of maybe canceling something out. So let's try it and see what happens. So we get 1 plus cos 2x. So 1 plus 1 minus 2 sine squared a over sine 2x, which is 2 sine a cos a. So 2 sine a cos a. So the top is 2 minus 2 sine squared a. The bottom is 2 sine a cos a. And I see on top that I could divide everything by 2. So let's take out a GCF of 2. What am I left with? 1 minus sine squared a. In the bottom, I have 2 sine a cos a. So I could see right away that these 2's cancel, and I know that 1 minus sine squared a is cosine squared a. That's one of those Pythagorean identities. So what can I cross off now? This cosine of a with one of these. So I'm left on top with simply cosine of a, and I'm left on bottom with simply sine of a. So my final answer is cotangent of a. Now again, that was my choice. My choice was to use cos 2x as 1 minus 2 sine a. This one. I could have chose this one, and I could have chose this one. And I challenge you to try the other one and see if you get the same answer. Okay, example number 3. It says if cosine of theta is 7 over 25, find cos 2 theta. So again, let's go back up to the top. They're asking for cos 2a. So let's pick one that has what? Cosine in it only, because that's the information that I have. Like if I were to pick, say, this one here, I have no use for it because they gave me cosine. So we actually have to pick this one right here. So 2 cosine squared a minus 1. So cos 2 theta, we're going to write as 2 cosine squared a minus 1. And look, they give you cosine a, or theta for this case. So let's maybe change this to a theta to make our life easier. So it's going to be 2 cosine squared. Well, I have cosine, which is 7 over 25. So all I have to do is square that and subtract 1. If you put this into the calculator, you'll get a large decimal. But what we want to do is actually just make it a reduced fraction. So negative 527 over 625. So see if you get that. Okay, so number 5. They're saying find cos 2 theta again, given that tangent is 5 over 6. Well, let's go back to the top again and look at all of my possibilities for cosine. So my possibilities again are here, here, and here. But none of them have tangent in it. So to be honest, it doesn't matter which one you pick. Let's just, for argument's sake, I don't know, pick one we haven't used before. Let's use cos 2a is this one, cosine squared minus sine squared. So let's first write down the formula. So cosine 2 theta is equal to cosine squared theta minus sine squared theta. Okay, I don't have cosine or sine. I have tangent. And they tell me it's a positive acute angle. So we know that that is going to be an angle in quadrant 1. So we can go ahead and draw the picture. We can go ahead and put theta where it belongs. Always goes here. And tangent is TOA. So opposite would be 5. Adjacent would be 6. Now, in order to find cosine and sine, I need the hypotenuse. So we can use the Pythagorean theorem for that. So this would be what? 6 squared plus 5 squared equals x squared. And you get 61 when you add them. So obviously you take the square root and you get x equals the square root of 61. So that would be my hypotenuse. So now, if I want to find cosine of the angle would be adjacent, which is 6, over hypotenuse, which is rad 61. So cosine would be 6 over rad 61 squared minus sine squared of the angle, so here's theta, opposite over hypotenuse, so 5 over rad 61 squared. Now you could put these in the calculator just the way you see it, and you'll actually get an answer, but I kind of want to do it by hand. What does it mean to take a fraction and square it? It means to multiply or raise the numerators to the second power and raise the denominator to the second power. So what's 6 squared? That would be 36 over. Now what if I take any radical and square it? I get the inside, so that would be just 61. Minus, what's 5 squared? 25. And the bottom, we would take radical 61 and square it. So any radical times itself, the radical goes away, so we get 61 also. So now you can put these fractions in the calculator in parentheses, and you should get 11 over 61 as your final answer. Okay, let's move on to the next page. Okay, so the next example says, if cosine of A is negative 5 over 13, where A is an angle between 90 and 180, what quadrant's that? Well, you should be saying quadrant 2. So let's go ahead and draw our picture. Here's quadrant 2. Here's angle A. Cosine again is adjacent over hypotenuse, so 5 over 13. And if you remember the Pythagorean triple, great. If not, you're going to use the Pythagorean theorem. This other side here should be 12. Okay, so now we want to find sine 2a, cos 2a, and tan 2a. So let's write down the formulas for all. So sine 2a equals 2 sine A cos A. So we know what sine of A is. Sine of A is opposite, which is 12, over hypotenuse, which is 13. So we can go ahead and put that in. That would be 2 times 12 over 13. And cosine of A would be adjacent, which is 5, over hypotenuse, which is 13. Now, what do I know about cosine, though, in the second quadrant? I know that this is A, S, T, C. The only thing that's positive in quadrant 2 is sine. So therefore, cosine has to have a negative. So if you put that into the calculator, just the way you see it, and reduce the fraction, you should get negative 120 over 169. That would be sine of 2A. So let's do cos of 2A. So again, you could pick whichever formula you want from the front. I chose this formula since we really didn't use it. So 1 minus 2 sine of A squared. So again, sine is opposite, which is 12, over hypotenuse, which is 13. So if you put this into the calculator just the way you see it, you should get 119, or negative 119, over 169. Okay, last but not least, tangent of 2A. The formula for tangent, if you look on the front, is 2 tan A over 1 minus tan squared A. So tangent of A is what? TOA, opposite over adjacent, so 12 over 5. But is it positive or negative? It's negative, because in quadrant 2, the only thing that's positive is sine. And then the bottom would be 1 minus negative 12 over 5 squared. If you do the numerator separate from the denominator, the numerator would be negative 24 over 5. The denominator would be negative 119 over 5. And then if you put that into the calculator separate, you should get 120 over 119. So try those out, pause the video, see if you can get those numbers. Okay, next example. Number 7. We're jumping to half angle problems. They're asking you to find sine of half x. So if you look on the front cover, there's a formula for it. And it says sine of half x equals square root, well, plus or minus, the square root of 1 minus cos x over 2. Well, lucky for us, they give us cos x. So let's just plug it in. Square root 1 minus 1 over 9 over 2. Now, I would put the numerator into the calculator, get a number, hit enter, then divide by 2. And if you do that, you should get 4 over 9. So we're going to take the square root of 4 over 9. Now remember, when you take the square root of a fraction, it's the square root of the top over the square root of the bottom. So what's the square root of 4? Simply 2. And what's the square root of 9? Simply 3. Now how do I know which one to take, the plus or the minus? You only can have one answer. It says x is a positive acute angle. So since x is positive, you're going to take the positive one, and the answer would be 2/3. You don't need the negative. Okay. I would like you to try question 8 for homework, and we will go over it in class. All right, we're all set. Bye.